Hello everyone, welcome to IIT's Gate classes. So in today's session, in our process control playlist, we are going to see the controller part. So controller is very important from your gate perspective as well as from your PSU interviews, whatever they are going to ask in your interviewer, it is going to be asked basically from controller. So this process control, I have already told that it is not important, not that much important from gate perspective, but it is quite important from your PSU interview. Why? Because many questions are asked from this process control. So let us see then what is our controller. So before starting the session, if you haven't subscribed to our channel, kindly subscribe to our channel. And if you like this video, please press the thumbs up button. And you can also comment your doubts, or if you like the video, you can comment something on the video. Okay. So let us then begin. Let me first ask you, what is a controller? What is the main task of controller? So controller, it is basically the brain of the process. Okay, brain of the process of a control loop. Okay, I have written over here. It is the brain of control loop. Now, what is the main task of controller? So the main task of controller is to control the value of controlled variable. Controlled variable means what? Your measured variable, your output, with the help of a control error signal. So the desired value of the output. So desired value of output is what? It is my set point, or also called as input in our control system, is equal to the reference value. Okay, so the desired value of the output is equal to the reference value. Okay, so this is what is the task of controller, that basically controller needs to maintain your controlled variable, that is your measured variable or output, equal to your input or to your set point. Okay, now, at some point of time, process load changes causes a change in control variable. Okay, so this might happen due to what? This might happen due to there might be some disturbance in the system, due to which your process load, it usually changes, or what happens, sometimes we change the input also. Okay, so due to that, there is a change, process load change, which causes a change in your controlled variable. Okay, so basically, how do my controllers, they get a signal that whatever is happening in the output, how do we get that? So we what do we have? We have basically your feedback control. So feedback control, it is ensured that variable returns to your set point. So all these things we have seen in our control system. What? That basically we have a feedback loop which usually does what? It compares your output with your reference value of the output, which is also called as input or also called as set point. Okay. So we have seen this thing on our control system. I have already discussed what is your reference input and all those things, measured variable, different types of variables, what is final control element. So this is my measuring instrument. Okay, so basically this is my set point. So the main task of this controller is what? Getting this error, which is actually the difference of this R and this C, means input signal minus output signal, or your measured value of the output minus, sorry, your reference value of the output, or the desired value of the output minus your actual output, that error signal we get. And basically what your controller generates an equivalent output which is given to a final control element. So final control element, according to the output of controller, basically makes adjustment in the process, so that basically this error, it becomes zero. Okay, so now let us see few things over here. What is process lag, what is control lag, and what is dead time? So these things are asked in interview. Okay, interview. So what is a process lag? Process lag is time taken by the process to respond to the actuation signal. Okay. Time taken by the process to respond to actuation signal. That means what? Whatever is the output, whatever is the output of final control element, how does this process reacts to this final control element's output, so that once again my error slowly starts reducing. That is what is called your process lag. Means what? How much time is taken by the process to make corrective action after final control element has given your input to the process. So that is what we call process lag. Now what is control lag? Time taken to make necessary adjustment to final control element. That means what? It is the time, suppose a disturbance enters in the process. So what happens? Basically, this is going to affect my output. Now this output is going to be measured by this measuring instrument, and this is going to be compared in this comparator, and my controller over here, it is going to make a decision that my error is increasing. So what it will do, it will generate an output. So this output is basically the input of final control element. So the time taken from this point to this point, and after that even the final control element has to make some decision. So that time from this point to this point, it is called as what? It is told as your control lag. It is the time taken to make necessary adjustment to the final control element. Okay. So from this point to this point, whatever is the time, it is called as control lag. Now dead time. So time between occurrence of error and its effect that shows on controlled variable. Suppose there is some occurrence of disturbance or error. Okay. So after how much time it is shown, or it is basically you're displayed on this controller, or after how much time that error it is getting detected in your this point in the controller, that is what is called as your dead time. Suppose a disturbance enters over here. So after how much time basically it is detected at the output, it is called as what? It is called as your dead time. So all these three times you need to know. So next over here, I have a simple diagram you can see, and I have made. So basically you can see over here what is my process lag, control lag, dead time. So I have also explained this over here diagrammatically. So control lag, you can see over here, it is the time taken to make necessary adjustment to final control element. So you can see this is the error. Okay, error. So error is given to your controller then gives your output u of t, and final control element then makes a decision. So this is all is called a control lag. From this error to your final control element, this is called as your control lag. So here you might think that I told so much of things from here to here. So it is the same thing. It is the same thing because some disturbance is going to affect the system. Okay, which is going to be detected by this measuring instrument, and this comparison is going to take. So from here to here, whatever time we take, that is known as your control lag. Okay. Next is dead time. So dead time means what? Suppose I told it is the time between occurrence of error and its effect that shows on controlled variable. So you can see any disturbance that had affected my process. Okay. So it is going to affect the C of t. If C of t is going to get affected, so it is going to be measured by this measuring instrument in the feedback loop, and it is going to be detected in this error signal. Okay. So that is what is your dead time. Process lag, I already explained. After applying u of t, time required to get new c of t is called process lag. So that means what? Why will you get new u of t? You will get new u of t. U of t is basically the controller output. Okay, controller output. So controller output, new controller output, why will you get? If there is some change in error signal. Now why will there be any change in error signal? If there is some change in your output, means your actual output. Okay, so then you will get that. Okay, so after applying u of t, whatever is the time required to get new c of t is called as process lag. Okay. Next we have is classifications of controller. So what is classification of controller? So we have different types of controller. So controller can be classified in two types basically. One of them is discontinuous, another is continuous. Discontinuous controller means what? All those controllers which operates in basically discrete positions, or they have basically discrete decision making abilities, like your simple switch. Okay, in simple switch what we basically have is your on and off. Okay, on and off. Now there can be three position switch also: on, off, or it is not even off and not even on. Okay, normal position. Like that also we can have. Then we can have multiple position, like 10. Suppose if I have a multi position valve, so which can close or it can open 10% of its final value, 20% of its final value, 30% of final value. So that is also what? It's a multiple position controller kind of. Next we have is continuous controller. So continuous controller can be proportional controller, integral controller, proportional derivative controller, proportional integral controller, and proportional integral derivative controller. Okay. So this is according to the position of the controller we are doing the classification. Next we have according to the power source of the controller. So we have electronic controller, so which operates either in 4 to 20 milliampere or 0 to 10 volt. Next we have is pneumatic controller, which operates in your 3 to 15 psig, pound per square inch, gram. Okay, so basically it operates in psig. Next we have is mechanical and hydraulic controller. So basically pneumatic, mechanical and hydraulic controller we don't need to study. Remaining all we are going to study over here. Okay, so what are the commonly used control terms that we are going to see now? Okay, that we are going to see. So commonly used controller terms that we are going to see over here. So basically this is what this R is, your set point. Okay, or desired output. Okay, this is your desired output, or we also call it as input in your control system. This C is what? This C is your output. Okay, this is called as your output, or this is called basically in your control system. In our process control, we call it as your controlled variable. Okay, we call it as what? We call it as your controlled variable. Now we have over here is this error. Okay, error. So which is actually what? R means this input minus C, whatever is your output. So this is basically what? This is my input to the controller. So input to the controller is basically given by this comparator, which compares two signal and gives me the subtraction or comparison basically. Now one thing always remember, that this R and C needs to be same quantity. Means what? Suppose if this R is electrical, so C should be also electrical. It cannot be pneumatic, it cannot be hydraulic. Because why? You cannot compare two dissimilar signals which have two different properties. Okay, electrical signals have different property, hydraulic or pneumatic signals have different property, so you cannot do that. So what is then U? U is basically the output of controller. Okay, so U is what? It is your output of the controller, or basically it is input of final control element. Also you can say it is the input of the final control element, or basically it is your controller output or output of the controller. Now there are few questions which is asked: error expressed as percentage of full span or scale. Now what is the span? So span is basically what? It is the value of the C max minus C mean. That means what? Whatever value this process output we have, So whatever is the maximum value of the output minus the minimum value of the output, that we call as span. Okay, that we call as span. So error expressed as percentage of full span or scale. So if error I want to express, so what we have over here is R. So my R is what? It is my set point. C, what do we mean by C? So C is my current value of the output, current value of output, whatever is the current value of output. Okay, so that divided by C max minus C min into 100. Okay, so that is what error expressed as percentage of full span or scale. Next we have is controller output expressed as percentage of full scale. This is also very important. Controller output, that means U, expressed as percentage of full scale. Full scale of what? Full scale of controller output. So controller output expressed as percentage of full scale of the controller. So whatever is the maximum value of the controller that we can get minus the U min. So this is going to be multiplied with the current value of the controller output, current value. So this is what? This is your current value of the controller output minus U minimum, whatever will be the minimum value of the controller output. So this is basically what? Controller output expressed as percentage of full scale. So once again, let me explain. Controller output expressed as percentage of full scale means what? Current value of the controller output minus the minimum value that your controller output can have divided by the span of the controller output. Okay, whatever is the U max minus U min. Okay. So next I have a question for you, a very good question. So solve this question, pause the video and try to solve this question within the next 2 minutes. So in this question, the pressure in the tank, it varies from 20 psi to 100 psi. That means what? C max or value of the maximum output, it is given as 100 psi, and value of the minimum output, it is given as 20 psi. The pressure in the tank is desired to be kept at 50 psi. So this is my set point. Set point is given as what? It is given as 50 psi. Okay. What is the full scale error when the pressure in the tank is what? 30 psi. So this is my current value of the output. So that is 30 psi. So we know basically the error formula, expressed as percentage of full scale, it is given by R minus C divided by C max minus C minimum into 100. So R is equal to what? It is equal to 50 minus 30 divided by 100 minus 20 into 100. So this will be 20 divided by 80 into 100. So this is actually 25%. Very simple question, previous year gate question. This is what we have. Okay. So next question, a controller output a 4 to 20 milliampere signal to a motor, to control motor speed from 140 to 600 rpm with linear dependence. Calculate the current corresponding to 310 rpm and the value of current in A expressed as percentage of control input. So RPM is basically what? This is my output. Okay, so this is my output and it is being controlled by this. A controller outputs a 4 to 20 milliampere signal to control motor speed. Okay, so basically it is dependent on what? It is dependent on this current signal. Okay, so basically I can write this as y is equal to mx plus c, where y will be what? This will be my RPM. This x, it will be current. We need to find this M and C so that for a current corresponding to 310 RPM, we can find out. Okay, so that we need to find out. So now let us see how to find out, or else we can keep Y also as current and RPM as input. Okay, RPM as input. So I am keeping it like this. So let us solve. For 4 milliampere, we will get 140 RPM. So let me write the first expression. 140 is equal to 4m plus c, equation 1. Next expression will be what? It will be 600 is equal to 20m plus c, expression number 2. Okay, so this is what we are getting. Now if we subtract 2 from 1, so this will be what? This will be equal to 460, means I am doing what? 2 minus 1, and this will be equal to 16m. So whatever is the value of m, we will get value of m as 460 by 16. So this will be 230 by 8, 115 by 4. Okay, 115 by 4 means 4 twos are 8, so 335. So 8 fours are 32, 3, so 720 means 28.75 we will get. Okay, 28.75 we will get for the value of m. Now what if we plug this value somewhere over here? Okay, somewhere over here. So what will I get? So let me put 140 is equal to 4 into m. So value of m, I can see it was 115 by 4 also. Why I have taken? So that I can cancel out this 4 plus c. So this gets cancelled. What did I get the value of c? Value of c I am getting as 15. Sorry, 25. Okay, value of c I got as 25. Now put this value to get what is the current corresponding to 310 RPM. So 310 is equal to I into m. What is the value of m? It is 28.75 or 115 by 4 plus. I can write this 25 as 100 by 4. Okay, why did I write it 100 by 4? So that I can easily take LCM. So 31, 62, 124. So this will be 1240. I have taken this over here, is equal to 115I plus 100. So this will be 1140 is equal to 115I. So whatever is the value, then you need to calculate what is the value of I. So I, if I want to calculate, this will be 1140 divided by 115. So if we solve this, so this will be 1140 divided by 115. So this will be 9.91. Okay, 9.91 milliampere we will get. Okay, 9.91 milliampere we will get. Next, the value of current A, current in A expressed as percentage of control input. Percentage of control input. So this is the current value of my input. Okay, so I can write it as 9.91. This is my current value divided by what is the minimum value of input over here. Input over here, you can see. So this will be equal to 4 divided by 20 minus 4. So this will be 5.91 divided by 16 into 100. So what value we will get for this one? Let me calculate. So 5.91 divided by 16. So this we are getting as 36.9%. So even if you had calculated using RPM, see this I had calculated using your current. Okay, current as my input. If you had taken RPM as your input, then also you will get it. Why? Because your current value of RPM is 310. Okay, 310. Because for 310 only you were getting 9.91, minus for 4 milliampere you were getting 140, divided by for 20 milliampere you were getting 600, minus 140 into 100. So if you solve this, you are still going to get 36.9% only. Okay. So very simple question over here we have. Next topic that we are going to see is discontinuous controller. So this is not that much. Once there was a question that bang bang controller is which controller, so you need to say it was on off controller. So there is a single question, and that we are going to see when we solve the previous year question. So in discontinuous controller, basically what we have is switching controller. So basically we keep on switching. Okay, we have is what we have is switching. So manipulated variable can take only few discrete value. What is manipulated variable? Manipulated variable is that variable with the help of which we actually what? We actually control the process. Okay. Or you can say basically it is the output of the final control element. So manipulated variable can take. So what I said, manipulated variable is what? Output of final control element. Okay, output of final control element. It can take few discrete values. Okay, so that energy to mass supply to the system can change in few discrete steps. Okay, it can change in few discrete steps. So basically what does your manipulated variable give? It is basically what? It is something output of your control valve. Okay, final control element, it can be a control valve. So basically what is a control valve doing? It is supplying either energy to the system like your steam, or it is going to supply mass like the flow of water, okay, to maintain the process at whatever is my desired value. So manipulated variable can take only few discrete steps so that energy or mass supply to the system can change in few discrete steps. Depending on the number of steps, if the number of steps are 2, we call it as 2 position controller. If the number of steps are 3, we call it as 3 position controller. So what position? Whose position? So basically it is the final control element's position. Okay, final control element's position. Next, if there are multiple positions involved, we call it as multiple position controller. So basically what? This is my final control element. It will give your control action. This is the output of the controller U. So input, if my final control element has output has only 2 positions, so I will call it as a 2 position controller. If it has 3, we will call it as 3 position. If it has multiple positions, or basically final control element can generate multiple positions, so we will call the complete controller and final control element as multi-position controller. If it has 2 steps, we are going to call this complete as 2 position controller. If it has 3 steps, we are going to call it as 3 position controller. Okay. Next, let us study your 2 position controller. So what do we mean by 2 position controller? So basically my 2 position controller, you can see it is also called as on off control. Okay, on off control, we call it as on off control. Also call it as open and close, and sometimes we call it as bang bang controller. So this actually was asked which controller is called as bang bang controller. So your answer will be what? A 2 position control, or an on off control is actually called bang bang controller. Why so? Because previously this control, why is it called bang bang? I will say previously this control used to be implemented using relay. And whenever a relay energizes or de-energizes, there is what? There is a sound which actually mimics the bang sound. Okay, bang sound. So that is why it is called as bang bang controller. Why we call it as open and close? Because the controller or the final control element has only two positions. Either it can open fully or it can close completely. Okay. So here you can see I have taken one simple example. If C is basically what? C is my actual output. This is actual output. Okay. Now let me take one example over here for you. So this is one sensor or measuring instrument. This is your controller. Okay, controller. This is your process. So controller is basically I have taken the combination of controller as well as final control element. Okay. Why to draw two blocks over here as space is not there? So now what is happening? Your controlled variable. Okay, controlled variable. Sorry, this is your C or actual output or controlled variable. This part is my set point. Okay, this is my set point. And over here we have our is controller output. So whenever you can see my actual output is above the set point, what will happen in on off control? Immediately the final control element, it will close or it will go to off. Whenever the actual value of output, it is less than the set point, your controller, sorry, your final control element, it will switch on, and this process is going to keep on continue. Okay, this process is going to keep on continue. How is it going to keep on continue? It is very simple. You might have seen your electric press. Okay, electric press. So suppose for pressing cotton clothes, the temperature of the press, it is 80 degrees Celsius. Okay. So the moment your press temperature, if it is less than 80 degrees C, if it is less than 80 degrees C, that means set point is 80 degree. If it is suppose just in the room temperature 25 degrees C. So what will happen? Immediately your press, it will switch on. There is a bimetallic strip, it will switch on, and the moment it goes above 80, okay, it goes above 80, but as there is energy, so what will, there is some energy in the coil, so heat will continue to build up, it will go till 85 suppose. So from 80, the moment it crosses 80.1 bimetallic strip, it will bend, and what will happen? My circuit, it will break off and no current will flow through your press. So heating, it will continue up to 85, but what will happen? Your controller or final control element, it is actually off. Okay. So here in this press, electric press, my final control element is your bimetallic strip. Okay. But what you can see, if suppose, what happens, this, let me draw one more diagram. Suppose I have a process where your controlled variable C is like this. This is my set point. So what will happen? You can see continuously, what will happen? My final control element, as here my controlled output is more than set point, so this will be off. So constantly this will switch between on and off, on and off, and very frequently this is going to take place, very frequently. Okay, so when this frequency is very more, what will happen? My system or my controller, it can get destroyed, because continuously it is getting energized, de-energized, energized, de-energized. So even if you have a simple switch at your home, and if there is a bulb connected to it, if you switch on switch off the bulb multiple times in a very short interval, what will happen? Your bulb, it might get fused. Okay, so the same thing, to avoid the same thing for such kind of process, what we do, we have a neutral band. Okay, we have a neutral band. So in this neutral band, what happens? We have a certain range of temperature or a certain range of output, control actual output, where your controller, it is not going to take any action. It is not going to take any action. Suppose for your, now my system is what? Air conditioner. Air conditioner. So my set point is what? It is 26 degrees C. 26 degrees C. Now immediately, if suppose, if 20, if the temperature goes above 26 degree, my compressor will start on and cooling will take place. And immediately if the temperature goes below 26 degree, what will happen? Your compressor, it will switch off and your AC will stop cooling. Now if this is very means, like if I go above 26.1, immediately what will happen? Compressor will switch on and cooling will start taking. If it goes below 26 degree, like 25.9, so what will happen? Compressor will switch off and cooling will stop. So what will happen? Constantly the compressor will switch on, switch off, switch on, switch off. Due to that, what will happen? The AC, it might get destroyed. So to avoid this, what we have a neutral band. So in this neutral band, suppose you have set the room temperature of the AC as 26 degree from your remote, but your AC will only switch on if the temperature goes above 28 degrees C, and the compressor will switch off if it goes below 24 degrees C. So now what will happen? The moment the temperature goes above 28 degrees C, now what will happen? Your AC will switch on, and the moment the temperature goes below 24 degrees C, it will switch off. Now you can see the cycle previously, which was taking place in a very short duration of time, this on off, now actually it is taking place in a larger time. So why, how is this helpful? Actually, it doesn't destroys the system, or it doesn't destroys my total complete compressor. Okay, so that is why we have this neutral band, actually to avoid this continuous energizing and de-energizing of my air conditioner. Okay, I hope up to this point everything is clear. Now if you have any doubts, what you can do, you can comment in the comment section below, and if you like the video, please press the thumbs up button. So now over here we have is what? This neutral zone. It is actually what? It is a desirable hysteresis. Now what do we mean by hysteresis? Hysteresis is actually the deviation in the input output characteristics of a system while loading and unloading. So that means what? Suppose I have a input output characteristics of a system, something like this. Suppose I have a weighing scale. Okay, electronic weighing scale. So in electronic weighing scale, suppose I am loading from 0 to 100 kg. So in an interval of 1 kg, I am loading. That means what? From 0, 1, 2, like this till 100, I am taking 100 measurements. I have a display over here. And what happens when I start, whatever this is output, this is input. So input is what? My weights that I am keeping over here. Output is the display. So while loading, the characteristics, it might look like this. That means what? When I am loading the weight initially, or gradually I am increasing the weight, it will look like this. So when I am unloading, suppose after 100 kg, I am removing 1 kg. So it might be 99, 98 like that. So ideally it should follow this path only. But what happens? There will be a slight deviation, something like this. So this is what is called as hysteresis. And this hysteresis is undesirable in a system. But in this neutral zone, hysteresis is actually what? It is a desirable characteristics in the system. So I have drawn the simple input output characteristics. So input output characteristics, this is basically your set point error I have drawn. So this is what? This is the graph you can see over here. So initially when this error is 0, this is off, controller output is off. As my controller output, it increases beyond certain value, you can see over here, beyond a certain value, what will happen? Immediately it will switch on and it will stay at that on position for a time. And then the moment it goes below a certain point, what will happen? My controller, it will switch off. So this is what you can see. It will remain switch off. And once again, this process is going to keep on continue. So this is kind of hysteresis. And always remember, hysteresis curve, it is cyclic in nature. Okay, it is cyclic in nature. Next, what we are going to see over here is suppose what? Okay, so already I have explained. Suppose if my this hysteresis curve, it has very less width. Suppose my air conditioner, the example I have taken over here, suppose if this was something like this. So if it goes below 25.8, immediately my compressor, it will switch off. And if it is going above 26.2, it will switch on. Okay, if it has very less width. Okay, previously the width, it was of near about 4 degree. Okay, because I had taken this below 2 degree and above 2 degree, so 4 degree range was there. Now I have taken only zero point 0.4, so I have reduced the neutral width by 10 times. Okay, so now what will happen? Once your AC, so I have taken 20 degrees. Once it reaches 26 degree, after that, what will happen? Continuous switching on, switching off, switching on, switching off, it will take place. Okay, switching on, switching off, it will take place, which will destroy. And if suppose the neutral width, it decreases gradually more, so what will happen? Constantly, this will keep on like this. Okay, so here you can see if I increase this like in 4 degree, so my neutral zone, it has increased. So now my switching on, switching off, it is getting delayed. So why it is desirable? Controller response when neutral zone is 0, the fast switching action may deteriorate the final control element in long term. Hence we use neutral zone, which I have explained already. So there is this question which I want you guys to solve. So this is also a very simple question. Once again, we are going to use y is equal to mx plus c. Okay. So I think here it should be level. Okay. Solve the question. So pause the video and solve the question. So in this question, a liquid level control system linearly converts a displacement of 2 to 3 meter into 4 to 20 milliampere control signal. So a liquid control converts a display of 2 to 3 milliampere, 2 to 3 meter into 4 to 20 milliampere. A relay serves as a two position controller to open or close an inlet valve. The relay closes at 12 milliampere and opens at 10 milliampere. Find first the relationship between level and current and the neutral zone in meter. So let me explain you the question. Suppose we have a tank. Okay, so we have a tank over here. In this tank, basically what we can measure from 2 to 3 meter. Let this be 2 meter. Let this be 3 meter. So for 2 meter, I am getting what? I am getting 4 milliampere. For 3 meter, I am getting 20 milliampere. Fine. A relay serves as a two-position control to open or close inlet valve. The relay closes at 12 milliampere and opens at 10 milliampere. That means what? So this is 12 milliampere. If it goes above, relay will close, and below 10 milliampere, the relay will open, causing the water to flow. Okay. So first you need to find the relationship between level and current, and second the neutral zone. Means this zone you need to find. Okay. So relationship between current. So what I am going to do, let me assume level is output and your current is input. Okay, so level is output, current is input. So if that is the case, what we can do over here is, I can once again write y is equal to mx plus c. Okay, y is equal to mx plus c. So let me assume y is level. This is current plus c. So let me write for 2, current is what, 4 plus c, and for, let this be equation 1. Equation 2 is what, for 3 meter, this is 20 milliampere plus c. So if I subtract this will cancel, this will give 16 m is equal to 1. So value of m is equal to 1 by 16. Okay, so if I put it over here in equation 1, so 2 is equal to 4 into 1 by 16 plus c. So this comes out to be c 7 by 4. So the value of c is 7 by 4. Simply plug this and you will get the relationship between level and current. So next you need to find neutral zone. So for finding neutral zone, simply what, put this current in this expression. Okay, so we have the value of m and c. So let me put that. Neutral zone will be what? Neutral zone in meters. So level corresponding to 12 milliampere minus level corresponding to 10 milliampere. Okay, so level corresponding to 12 milliampere will be what? M is 1 by 16. So 1 by 16 into 12 plus 7 by 4 minus 1 by 16 into 10 plus 7 by 4. So obviously this 7 by 4 will get cancelled, and over here we will have 2 by 16. So 2 by 16 I got, that is 1 by 8, or 1 by 8 is 0.125 meter. Okay, so answer is in very simple question. Okay, very simple question. So next we have is 3-position control. Okay, what is this 3-position control? Let us see. So in 3-position control, basically what we have, it is an extension of 2-position control. So what? It can be in a heating system, either your coil, it can be on, it can be off, or it can be cooling. Like in your car heater, car air conditioner, there are 3 processes going on. Either you can keep the air conditioner off, or you can keep the air conditioner on, in which there will be cooling. Your temperature will slowly, gradually decrease inside the car cabin. And next there might be a heater system, so which you use in the winter, so it gradually increases the temperature in the car cabin. So there are 3-position control, and nowadays even your AC, they have heating control inside. You can take the temperature up to 50 degrees Celsius. Okay, so those things are available. Similarly, in a valve, we have a counterclockwise open. All the valves, they open in counterclockwise or anti-clockwise, and they close in clockwise. Even your home taps, they open like that and close. At the third position, it can be stay where it is. Okay, so this is what? This is my 3-position control. Next we have is a time proportional controller. So now what is this time proportional controller? So time proportional controller, here output of the controller is continuous, but output of the final control element, it is discontinuous. What I said? Output of the controller is continuous, but output of the final control element is discontinuous. Like suppose I have a pipe. Okay, pipe I have. So there is a valve. Now this is not the symbol of valve, or let me draw it properly. Okay, I have a valve over here. Now controller is also there. Okay, controller is there. Now I am measuring the flow from here and giving proper output to this valve. Now assume whenever the flow over here, it is less than 50 meter cube per second. Okay, 50 meter cube per second. What will happen? This valve will open. Valve open. Next, another case, suppose if so less than this, valve open. 100 meter cube per second, valve closes. Okay, so now this controller, it is measuring. So for 60, what will happen? Control signal going is open. For 70, it is going, it is giving you open. So controller is continuously taking measurement. Here my controller, output of the controller is continuous. You can see continuously it is giving output. For 50 also it is giving output. For 60 also giving output. But this final control element, it is discontinuous. It is operating in only two places. Either if when this is less than 50, it will open. If it is greater than 100, it will open. Okay, so it is what? It is an extension of your on off controller. So final control element has only two position, but the time for which it will remain in this two position will vary with controller output. Okay, so what that means, what there are set points beyond which your control final control elements output is going to change, but controller will generate continuous output or continuous input for the final control element, but your final control element, it is going to react only for your two set points. Okay, so that is the case. Next we have is the continuous controller, so that we are going to see in the next class. I hope you have liked this session. If you have any doubt, you can post it in the comment section below and let me know. And if you like the session, please press the thumbs up button. And if you are new to this channel, please subscribe to our channel. So see you in the next session with continuous controller. Thank you.